Greetings everyone. We are AppPal team, ITM major in Seoul Tech University of Science and Technology. Presentation about design and implementation of 3D drawing service using augmented reality and biometrics technology. Contents will be preceded with motivation and observation about related works, objectives and implementation, and finally, result and conclusion. Within few years coming, biometric market is expected to grow gradually, and the growth of VR/AR market is also predicted to increase nearly 16.5% per year. Following expanding hardware market, related software market is observed reactivating. By this prediction, we would like to suggest the 3D drawing application with hand recognition and no additional equipment. Explanation about related work. First one is Portalware. It is Android application based on AR Core, which is the AR environment implementation service from Google and produces 3D drawing function in AR. For the features, we can do the interaction by the hand with a specific equipment shaped in a thimble on the thumb. For the limitations, 1. Specific requirement is required. 2. Multiplaying is not available. And 3. Touching screen is necessary for accessing user interface and functions. Next one is Just Align. Likewise, it is the Android application based on the AR core and produces 3D painting in AR. For the features, unlike Portalware explained, it doesn't require any additional equipment and provides basic multiplying function. For the limitation, 1. There is no functions related with biometric. 2. Multiplying requires the same physical spaces. And 3. Drawing function is only available for free line drawing. Last, MediaPipe hands. It is AI framework for recognizing hands provided by Google. It allows extraction of hand location data from image or video in real time. For the features, it produces location of hand in video as formation of 3D coordinates. But after internal verification, we confirmed that accuracy of Z coordinates, which is the depth, is noticeably low. Through exploring related studies, we would like to suggest the 3D drawing service without physical limitations. Here's core concepts. 1. Biometric interaction with functions by MediaPipe hands. 2. Implementation of 3D drawing based on Google AR Core. 3. Implementation of multiplaying between physically separated spaces. Design and implementation. First, the procedure for introducing gesture recognition model based on deep learning. We use recorded video by webcam as the dataset and train LSTM model with Python. Since the performance required for gesture recognition module, we conclude to separate recognition module from the application and construct socket server for it. Socket server is implemented by Python. It receives the coordinate data from the application and predicts the current gesture. After predicting, it sends the result to application. Next is the implementation of application functions. It utilizes the gesture received from socket server. Gesture recognition is done in real time, and by using it, user can access to change the drawing tool, thickness, and the color. Referred by the Portalware and Just Align, which has only one free line drawing function, we additionally implement straight line, rectangle, and cube drawing. The process is 1. Track the initial and end point and connect them. 2. add points for each unit interval, which makes partial deletion available. Also, based on straight line, by utilizing the calculation of coordinates, we succeed to implement rectangle and cube successfully. Last one is drawing with hand, a core function. As described before, depth coordinate from the media pipe was not stabilized, which leads us to conclude that we need new logic for depth. We decide to estimate the distances and angles by calculating the coordinates, which is located in the present border of the hand. For deciding whether user is drawing or not, we use the distances and angles of starting and last point of thumb and index finger. If the peak of thumb and index finger are touched and the angles of formed triangle are not over 120 degrees, then it is determined as drawing. Management of data is done through the Google Firebase real-time database. The reason we chose this server was the implementation of real-time multiplane. The typical server frameworks based on RESTful structure, such as Spring in Java or Express in JavaScript, was not appropriate structure for real-time synchronization, which we need for the real-time multiplane. After checking the functions provided from Google Firebase real-time database, we agreed that it also satisfied the functions we require, and it would be more stable than constructing additional socket server we needed, so we conclude to use it. Result of implementation. Gesture is settled into 6 types, 0, 1, 2, 3, 4, and 5 as the counting fingers. We decide to counting 3 like the rock symbol because in a typical way of counting 3, the accuracy of prediction model was significantly low. By numeric gestures, we observe the access to UI and functions are fully working with hands as we intended. And for the AR spaces, we confirmed that the allocation of virtual space based on current physical space and drawing in the vertical space are working properly. We also checked the multiplane between physically separated spaces are working while displaying drawings for both screens. Now let's see the demonstration video for the result. Conclusion. By this project, we figured that 1. UI interaction based on non-contact biometric technology is available. 2. Service with virtual space based on separation of spaces is available. And 3. Additional equipment is not necessarily required for the services explained in previous. By the performance above that additional equipment is not necessary for implementing services based on virtual space, we expect to apply and utilize this in various fields. Thank you.